In 9.5, we are going to go through compositions of transformations. And what that is when we have more than one transformation put together. So what we've actually done in the last two video notes is we've done a translation and then a reflection, or a translation and then a rotation, and technically that is a composition. So first, one more specific is a glide reflection, and a glide reflection is when we take a translation, and then the transformation that follows is a reflection. So you can see in this picture on the side that PQ is first translated, so slid up, and then it's reflected over the line K, and it ends up right over here. And that's called a composition because it was a glide reflection, so it glided, or translation, and then reflected. So a composition of transformations is when we have two or more transformations and are combined to form a single transformation. And a composition of two or more isometries is still an isometry. So even if we combine two of our transformations together, if it starts an isometry, so it starts being congruent to each other, then it will still be congruent in the end. In this question, we need to look at all four choices, and we need to figure out which composition transformation maps this triangle onto the next one. So remember, our y-axis that's mentioned in 3 of these is right here, and our x-axis that's mentioned in 1 of them is right here. So let's start with the one that's the x-axis, since there's only one of those to check. And it says reflected over the x-axis. So if here's our little picture, that would mean it would be upside down like that, and then shifted up 6 spaces. So that would be upside down. It's not going to work like that. So we know it cannot be B. So now let's check the other ones. Let's start down here at the very bottom. So it reflects over the y-axis, so be over here, and then reflects over the x-axis, and then down 4 spaces. Okay, so that one's a little intensive, so let's check that one out. Let's kind of sketch it out. So if we reflect it over the y-axis first, sorry, it would look like that. Then it would be over the x-axis, and then down 4 spaces. But if this is the shape it's going to be upside down as well, so we don't want that one. Okay, so for letter C, if it goes over the x-axis, that might work, and then shifted down 4 spaces, that's going the opposite direction. That would be down too low. So down too low, so that one's not going to work. So let's check this other one. So if we reflect it over the y-axis, it would be 2 spaces away on the other side. That's what it would look like if I reflect it over. Then I need to move it up 6 spaces, so let's check that out. So 1, 2, 3, 4, 5, 6. And it does end up in the right spot. So letter A is our answer. On here, it is just a bunch of definitions that we might be using off and on. So in this first one, if you notice, we take the blue figure, so a very pre-image, we reflect it over this line, and then we reflect it over another line. So one thing that you're going to start to notice on some of these is, say the distance between here is 10. That means the distance between the very beginning coordinate and the very ending one is going to be double that amount, so it's going to be 20. So that's one of the rules right here in number 2. We can also see that if our 2 points, if you connect our lines together like this, they are going to be perpendicular to the lines, our parallel lines, to begin with. So then in this next picture down here is if we take one segment, we rotate it, reflect it first over one line and then reflect it over another line, but the angle that the 2 lines crossed each other to begin with was x, then that means that the angle created from the beginning segment to the ending one is going to be 2 times the x. So if the original one started as, say, a 50, that the whole angle then would be 100 degrees. So it's going to be double that size. So here's where I can show you more specifically about those other lines. So if we have a segment that's reflected over a line and then reflected over another line, and those 2 lines drawn to begin with right here in purple are parallel lines to begin with, then that means we can answer some of these questions. So the translation maps segment AB onto which segment? So the translation, remember, is it just slides. The only one that it slid to, it would have to be A double prime, B double prime. All right, so next, which lines are perpendicular to B double prime? So if you look right there, which lines are perpendicular to that? And that would be our two parallel lines, so line K and line M. Lastly, name two segments parallel to A double prime. So A double prime, so some lines that are parallel to that would be right here, so B prime, and we can say B double prime. So B and then B double prime, because if they started out being the same distance away, they're going to be the same distance away in the very end. So we've got a couple different line segments there that are parallel. All right, so the pre-image is reflected in line K. So if you notice, the blue one is our pre-image. And then it is reflected, so it's reflected over here, and then it is reflected again. And what happens is that it ends up rotating. So how does it map the blue onto the green? So the blue onto the green part. How do we get from there to there? And it is basically you're rotating it 160 degrees about point P. And the reason I know it's counterclockwise is because we're reflecting in that direction, but also the reason I know it's 160 is because I need to take 80 times 2 and I get 160 degrees. In this question, we're going to reflect it over, or point over the line x equals -3, and that's already drawn on here for us. So if you notice that this point is 1, 2, 3, 4 spaces away, so we want it to be 4 spaces away on the other side. So if I count out 1, 2, 3, 4, that's where it should end up being after reflected over the line x equals -3. Then I need to reflect it over the line y equals x. So remember, if we go diagonally, here is our line y equals x because our slope is 1 and our y-intercept is 0. And to go directly connecting it to that line, I have 1.5 spaces. So I need to go 1/2 and then 1 full space on the other side. So that's where it would end up. And that point is at 4, 2. Or 4, 1, sorry, I cannot count. So 4, 1 is where it ends up after I reflect it 2 times. In this problem, we have a set of parallel lines we are starting with first, and we need to reflect it over the y-axis and then translate it to the right and then 1 space down. So if we take each of the coordinates, if we reflect it over the y-axis, that would be right here, and then 1, 2 to the right and 1 down. All right, so next, if I take this coordinate and I reflect it over the y-axis, so it's 2 away right now, so 2 away on the other side, then I need to go to the right 2 spaces and down 1. This is where it would end up. All right, so for this other parallel line, my red one, I can reflect it over the y-axis, so it's 2 away, so it goes right there. Then 2 to the right and 1 down, so it would end up right there. Next, if we do our other coordinate, so we reflect it over the y-axis, sorry, so it's 1 away, so 1 away. Then I go to the right 2 and down 1. This is where it would end up for my red point. So when I connect those together, this is what our picture looks like. So we have the original ones and then the translated ones, and reflected, the composition, sorry. Okay, so the lines intersect at 2, -1. 2, -1 is right here. The lines do not intersect at that point, so it's not letter A. Next, do the 2 lines do not intersect? That's true. So that part right there is true. They have the same distance apart as the original set of lines. Yes. Okay, so letter C, the lines do not intersect. That's true. And are further apart than the original set of lines. That part makes it so it's not true. Letter D, the lines do not intersect. That is true. And are closer together than the original set of lines, and that is not true. So the only answer that works all the way through is our letter B. So here's a question we are going to do. So we have the 3 coordinates, A, B, and C. We need to graph the image of triangle ABC after the composition of the transformations in the order they are listed. So first we need to translate it, and that means that we need to subtract 6 from each of our x's, and we need to add 1 to each of our y's. So that gives us A prime is at -3, +2. B prime then would be -5 and a 6. C prime would be a -1, +4. Next, we need to rotate 90 degrees about the origin. So 90 degrees, our rule is -y, +x. So my A double prime is going to be, since the x's are now moved to the y position, my 3 will go there, my -5, and then my -1. For the y's, I need to take my y and I need to put it in front and then change the sign. So I need to take my y, put it in front, and change the sign. Take my y, put it in front, and change my sign. So there's where my 3 coordinates are to end up with. So let's go ahead and graph those coordinates. So our final coordinates are these 3 right here. And my A double prime, my B double prime, and my C double prime. And I just did double prime because the first transformation was my A prime, and then after I did my rotation, then I did a double prime to show that there was 2 separate steps.